In this video, you will learn how to solve quadratic equations by using completing the square. Now, to understand how completing the square works, we first need to understand how to solve equations with perfect squares. So let's do a little bit of review. Here we have example 1, where we have y squared equals 49. Well, to solve this, because the squared term is all by itself, we can take the square root of both sides. If we take the square root of both sides, on the left side, the square and the square root undo each other, and I'm left with a y. On the right side, the square root of 49 is 7, so we have a positive or negative 7. So my solution is y equals positive or negative 7. Now for example 2, we have y minus 6 squared equals 49. Now it's the same idea as example 1, where this left side is a perfect square, so I can get rid of the square by taking the square root of both sides. When I do that, the square and the square root undo each other. I'm left with y minus 6 on the left side, and then a positive or negative square root of 49 on the right side. The square root of 49 is 7, so we have a positive or negative 7 on the right side. And then to solve for y, we can add 6 to both sides. Now we have y equals 6 plus or minus 7. So what this means is that we have 6 plus 7, or y equals 6 minus 7. So 6 plus 7 is 13, and 6 minus 7 is negative 1. So y is 13, or y is negative 1. Example 3, we have 5y minus 6 squared equals 49. So this one again is the same process. Because we have a perfect square on the left side, we can get rid of the square by taking the square root. When I take the square root of both sides, on the left side, the square and the square root will undo each other. I'm left with 5y minus 6. And on the right side, we have a positive or negative square root of 49, which is a positive or negative 7. So then we can solve this by getting rid of the minus 6 and the times 5. Working in reverse order of operations, we take care of subtraction first. So we add 6 to both sides. We now have 5y equals 6 plus or minus 7. And then we can divide both sides by 5. So now we have y equals 6 plus or minus 7 over 5. So this plus or minus means that we have two different answers. One would be 6 plus 7 over 5, and the other would be 6 minus 7 over 5. Well, 6 plus 7 is 13, so we have 13 over 5. Or 6 minus 7 is negative 1, so we have negative 1 over 5. So my two answers would be 13 over 5 or negative 1 over 5. So if you understand this concept where if you have a perfect square on one side and a constant on the other side, we can then use that to take the square root to solve. This concept is going to be what drives the process of completing the square. So in the following examples, it will not be in this format, but I can make it or force it to become in this format so that then I can take the square root of both sides to solve. So as we progress, make sure we have the constant on one side, and then we have a perfect square on the other side. So let's begin with our first example of completing the square. Here we have x squared minus 8x minus 3 equals 0. So this one, we would notice, does not factor. So factoring should be kind of our first method to look for to see if we can solve. Factoring does not work. So because of that, I need some other way or some other method to solve this equation. So what I can do is I could use completing the square method. And there's also other methods, by the way, in which you could solve quadratic equations. You have factoring, this is one method. You have here in this lesson completing the square. And then you'll also have what's called the quadratic formula. So the quadratic formula will be a later lesson. So right now what I want to do is force this left side to be a perfect square. So to do that, I need the constant on the right side. So move the constant to the right side. We see here this minus 3. Let's move it over to the right side by adding 3. So now we have x squared minus 8x equals 3. Now what I want to do is add something to both sides of the equation so that this left side will become a perfect square trinomial. Right? Because my end goal is I want this left side to be something squared and then this right side to be some number. So I'm forcing this to become a perfect square. And to make that happen, I add something to both sides of the equation. Now what I add is found by looking at this middle coefficient, this -8. What I do is I take half of that number, so divide by 2, so that gives me -4, and then once I find that number, I square it. So -4 squared is 16. So again, I'm going to take half of this middle term and then square it. So half of -8 is -4, square it, and you get 16. So what I'm going to do is I'm going to add 16 to both sides of the equation. And that's what we see right here. We add 16 to both sides of the equation. And we did that because now this left side, x squared minus 8x plus 16, this will factor. And this will be a perfect square. Because when I factor, I'm going to get x times x to get x squared, and then I get 16. If we do a -4 times a -4, that would give me a positive 16 and would add to give me a -8 for the middle term. So this factors to become x minus 4 times x minus 4, which is x minus 4 squared. And that was the whole point of doing that. So this factors to be x minus 4 squared, and then the right side, 3 plus 16, is going to be 19. And by the way, you don't want to have to go through this process of factoring every time. You want to make sure you can do this quickly in your head. And a quick way to know what is going to go right here is because we take whatever number we squared to get to the 16. Well, remember back here we took half of -8 to get -4 and then squared that number. This -4 is what's going to go right in here. Alright, so when you factor, it's going to be x minus 4. Now at this point we have a perfect square on the left side and a constant on the right side. So from here I can take the square root of both sides. So take the square root of both sides, and you see that right up here. And when I do that, on the left side, the square and the square root will undo each other. So I'm left with an x minus 4 on the left side, and then on the right side, we have a positive or negative square root of 19. And then from here, we can solve for x by adding 4 to both sides. So now we have x equals 4 plus or minus the square root of 19. So this here is your final answer. And if you wanted to use your calculator to get a decimal answer, you could do that as well. Just remember, you would have two different answers. One is 4 plus the square root of 19, and the other is 4 minus the square root of 19. So I would consider this a level 1 difficulty type of question. And the reason is, first of all, the number in the front of the x squared term is an understood 1. Okay, there's nothing in front of the x squared term. And then also, this middle number is an even number. Alright, so because it's even, when I take half and square, we're going to get a whole number back out. Whereas if it was not even, let's say it was a 7, for example, if it was a 7, when you take half and square, you get 7 over 2 squared, which would be a 49 over 4. And so you'd have these fractions which make it really messy when you're trying to add and subtract. So for this reason, this would be a level 1 difficulty. Now the thing is, this process only works if the coefficient of the x squared term is a 1. Right? If it's not a 1, I need to make it a 1 so that I can begin my process. So for example, here we see what I would consider a level 2 difficulty type of problem. So first off, we see that this coefficient with the y squared term is not a 1. So I need to make it a 1. Alright, so we'll do that in a moment. Let's first put the constant term on the right side. So this minus 5 right here, let's move it over to the right side because we'll need to do that anyway at some point. Might as well do it right now. And so if I add, we now have 2y squared plus 2y equals 5. Okay, and as I said, we want to make this y squared term into a 1 in the front. So to make that happen, I need to divide everything by 2. When I divide everything by 2, this becomes a 1y squared. This becomes 1y. And this becomes 5 over 2 on the right side. So we see already that we have a fraction, which is going to make this difficult. So to do the completing the square process, on this left side, I'm trying to make this into a perfect square. So I want this to be something squared on the left side, and then some number on the right side. Well, to force this to become a perfect square, I need to add something here and add something over here. So what I add is found by taking half of this middle number, which is an assumed 1. So take half of that number and then square it. So 1 over 2 squared would be 1 over 4. So this would become a 1 over 4, which I would then do to both sides. And now I can factor this left side. This one's not as obvious because now we have a fraction right here. I mentioned in a previous example that a quick way to figure out what goes here is look to see what we had to square to get the 1/4. And we notice right here that number is 1 over 2. So that becomes a 1 over 2. And then on the right side, 5 over 2 plus 1 over 4, I need to find a common denominator. So common denominator would be 4. So the first fraction, 5 over 2, you can write as 10 over 4. So 10 over 4 plus 1 over 4 is 11 over 4. So now I have forced this left side to become a perfect square, which I can then get rid of the square by taking the square root of both sides. So take the square root of both sides, and the square and the square root will undo each other. I'm left with y plus 1 over 2 equals, and plus or minus the square root of 11 over 4, which, by the way, you can separate into a plus or minus square root of 11 over the square root of 4, which would be 2. And we see all the work we just did typed up, and we're at this point right here. Alright, so to solve for y, we can subtract 1 over 2 from both sides. When I do that, this will cancel out, and I now have y equals, it's going to be negative 1/2 plus or minus the square root of 11 over 2. And that's what we see right here. And if we wanted to, we could take this one step further, combine it to one fraction, where we have negative 1 plus or minus the square root of 11 on the top, and my denominator would be a 2. So notice this is very difficult because we have fractions in here, which just makes the problem more difficult to solve. So if you realize that there's going to be fractions like this, completing the square is probably not the best method. And so if factoring doesn't work and we see fractions here in completing the square method, the best method would probably be quadratic formula, which will be the next lesson. And believe it or not, these problems could get even more difficult. We could have a level 3 difficulty, where, for example, we have 2y squared plus 3y minus 5. And we're not going to solve this all the way, but I'm going to show you how you would have to set it up. Okay, you want to get this constant term on the right side, and we do that by adding 5 to both sides. So now we have 2y squared plus 3y equals 5. And then at this point, we want to make sure that this first term, this y squared term, is going to be with a coefficient of 1. So to make that happen, I'd have to divide everything by 2. So now we have y squared plus 3 over 2y equals 5 over 2. So notice now not only do we have a fraction on this right side, but this middle term is also a fraction, which we know is going to be very difficult to do because the number we have to add to both sides has to be half of that, which is 3 over 4, and then squared, which would be 9 over 16, which you'd have to add to both sides, and then try to figure out how to factor that left side. So it can be done, but it's going to be a tedious process because of all the fractions. So if you see fractions in the problem, completing the square is probably not the best method. It can be done, and if you're good with fractions, you're more than welcome to use this method, but I would recommend the quadratic formula.